working with new or tilled soils in the landscape. The soil is a mixture of mineral matter, organic matter, living organisms, air, and water. The mineral matter is composed of sand, silt, and clay particles. The proportion of these mineral components is what forms the texture of your soil. The soil water contains dissolved minerals and is the main source of water and nutrients for plants. The air in the soil is needed for plant roots and soil microorganisms to obtain oxygen. The soil organic matter includes a variety of plant and animal debris in different stages of decomposition. All these components are interconnected to support the soil ecosystem, either artificial or natural. In short, the soil is the habitat for many organisms such as bacteria, fungi, protozoa, nematodes, worms, and arthropods that have an effect on plant growth and establishment. Bacteria makes the glues that hold clays, silt, sand, and organic matter together. Fungi are strands that make glue and threads that hold bacterial aggregates together. Protozoa control bacterial populations. Nematodes open up larger pore areas. Microarthropods engineer the larger pores. And roots engineer the freeways. New landscapes present a major challenge to restore healthy and sustainable soils that will support introduced vegetation. Usually, organic matter is low or depleted, and the challenge is to build it to levels that can support the beneficial soil microbial populations. The addition of soil amendments such as compost to increase soil organic matter is beneficial in the short term, as decomposition by bacteria lead to a peak and valley long term. The ideal situation is to create the correct cultural conditions for the system to sustain microbial populations associated to the vegetation, as this slowly builds up the organic matter to optimal levels necessary for chemical and biological soil processes. One of the more complex issues that need to be dealt with in regard to establishing plants in new soils is reducing the migration of vines running through the soil profiles due to a lack of biological glues. Water weighs 8.3 pounds per gallon, and combined with gravity often moves rapidly through the sandy soil, taking portions of clay, silt, and organic matter. This creates a depositing of these mineral particles deeper in the soil, which often creates a self-compacting layer. Unfortunately, a byproduct of creating these well-textured soils is the living component, or soil food web, which becomes damaged in the process of blending. Having a healthy soil food web in place provides the needed glues to bind silt, clay, and sand particles. Field trials performed at the Rodale Institute compared biological systems of management to conventional systems, which clearly demonstrated the benefits of building soil structure and root mass when working in sync with both plant and soil biology. New engineered soil using the conventional system produced a 4 to 5 inch root mass over a 7-week period, while the biologically managed sod in the same soil developed close to 30 inches of root mass in 7 weeks. In this picture, you can see the classic self-compaction that occurred in the conventional system, where the biological glues and root mass were limited. And this is where the biological system was working at optimal levels a healthy, well-structured soil developed. Traditionally, land care professionals have used compost as a top dressing to increase organic matter and biological activity. Recent research indicates that using compost as a top dress can lead to layering in soil profiles. Liquid biological amendments work with moving the bacteria, fungi, and protozoa through the soil to where it is most beneficial around the roots and create structure. Liquid biological amendments require artisan-made compost rather than municipal organic matter. The entire soil food web needs to be in high volumes in order to make an extracted biological dense solution. Creating high-quality liquid biological amendments is not only a craft, but has also allowed us to bridge the gap that took soil, plants, and organisms millions of years of evolution to create. Using eco-pile technology rather than compost gives us greater flexibility to grow site-specific indigenous organisms to harvest and then reintroduce to the new landscape. The liquid biological amendment is then applied at concentrated rates on soil, plants, grass, or injected into tree root balls to establish the natural system that provides the glues to create structure, natural nutrient cycling, and overall plant protection. New field tests such as the patented biometer allows immediate diagnostics of both liquid biological amendments quality as well as assessing on-site benefits of application. One of the most important pieces to developing new landscapes are the plants, photosynthesis, and their associates. Carbon and sunlight captured during photosynthesis is made into food that fuels the plant's growth and also released through the roots to feed the plant's beneficial organisms, as well as provide carbon for mycorrhizal fungi that live symbiotically with the plant and soils. These fungi are responsible for nutrient and water uptake and only get their carbon from the plant. FAM mycorrhizae also release glomalin, which is a sticky carbon substance that binds soil particles together as roots grow through. Building healthy, self-sustaining landscapes is an adaptive working knowledge of soils, plants, and higher trophic life, which all sing together along with the seasonal rhythms to create a dynamic and aesthetically pleasing landscape. Visit us at elmscapes.com.